All right, this is MCT4C, day in around 15. We're going to be doing lesson 2.5, which is writing sinusoidal functions. I kind of think of this as the Jeopardy day where, we're given the answer, which is bits and pieces information about a trig function, and we have to come up with the equation. But for the 3-minute review, we're just asked to identify key features of a given sinusoidal function. Sinusoidal function means ones that can be written as sine or cos. Okay, we think of sinusoidal as either sine or cos, and we'll see that the two are very similar today. All right, well, let's start picking off all this information. Amplitude, well, that's the number A. The amplitude is just 3.2, and that's A. The period, remember the little expression for the period is 360 divided by B. Now, B is 4.5, and that is 80. And then the phase shift. Phase shift is opposite that you'd think in the direction of X. Phase shift is left, 172 degrees. Check, check, check. Vertical shift is this n number affecting y values up 53.2, which also means the equation of the axis. I've been interchanging these. The equation of the axis would be the line y equals 53.2, if we wanted to say that. Minimum. We think of the minimum, well, it's the axis is 53.2, but then we go down 3.2 from there. Minimum goes down to 50. Maximum from the axis up 3.2, which is 56.4, I believe. And then the domain, I don't even know why I bother asking for domain still. I guess it's just a habit. It's all real numbers, right? I could put any real number in there and then jam it into a calculator if I wanted to. The range, of course, is a little more interesting. It's between the minimum and the maximum. What we're going to see soon, not today, is, these sorts of things, these strange numbers, a period of 80, a range of decimal numbers instead of nice numbers that we can graph, we can use this sort of thing to model real life situations. Like, I don't know, almost anything that's periodic, like for instance a Ferris wheel, right? So if we had a Ferris wheel, and this isn't a very good example, but because the range, it doesn't quite fit. But if it took 80 seconds to go around a Ferris wheel, this might model the height of a person, right? What's weird is that means this Ferris wheel would go between 50 feet off the ground to 56 feet off the ground, which isn't quite realistic, but these numbers soon will match some sort of situation in real life. For today, we're just interested in writing sinusoidal functions given some stuff. Like I said, this is the Jeopardy day. I write the equation of a sinusoidal function given a description of its properties. So it says write an equation of a cosine function that has an amplitude of 6 and a period of 120. Well, if it's a cosine function, it's going to be in this form, right? And this will be something that we're coming back to over and over today, is then we just got to find values for A, B, C, and D. Well, what ones are we given in the question here? Well, the amplitude is 6. No problem. The period is 120. Well, that's got something to do with B, but that's a little bit of work, right? So I'm going to do a little work here. I know the period is just 360 divided by B, right? But that answer is 120. So I'm going to write this in a different way. And I know that some of you, because there's not many of these, right? There's only a certain values of B that we're interested in. Little proportion here, I can cross multiply, divide both sides by 120, and I get B is 3. Notice that that's all the information the question is. So what are these values? Well, we don't really care, do we? They could be 0. And then if I had B is 3, notice that this looks a little bit strange in here. If D is 0 and C is 0, we wouldn't write those in, right? And in fact, these brackets, when it's x minus 0, we wouldn't write that in there. That's not necessary. We'd write just 3x. So for the equation you wrote in part A, list other key features. Well, these are the ones that we kind of picked to be 0. The axis, or the vertical shift, is 0. Or the axis, those are the same thing. The axis was just y equals 0, the x-axis. And the phase shift was also 0. So are other equations possible for your function? Yes. Of course, all we would have to do is pick some other values of C and D, and we'd get another cosine function that also had an amplitude of 6 and a period of 120. Any other phase shift or vertical shift. Notice also that if we had A being negative and it was a flip in the x-axis, that the cosine function started at its minimum instead of its maximum, that would also be a possibility. All right, onward. A sine function has an amplitude of 0.5 and a period of 180. It goes through that point. Write an equation is more than one equation possible. So this is a little more information. Notice if I write down the equation, this is everything, right? And then we'll start picking some, and if we've got some choice, then we'll say, is more than one equation possible? Yes. But let's think about this. Okay, an amplitude of 0.5. And remember, we talked about this last time. If it suits us that that's minus, just so this matches up, we could do that. A period of 180, well, that's a B, a value of B that's not 1. If this is 360, B is just 1, but again, a little bit of work. .360 divided by B is 180, and hopefully you can see if I wanted to cross multiply I could, but B is 2, isn't it? I'm just going to ... B is 2. Cross multiply divided by 180, you get B is 2. So what are the things left over? Again, the phase shift and the axis, but we've got this extra information that it's got to go through the point 360, right? So they're 361. So I know I'm going to have to graph down here, but I'm doing a rough sketch over here, okay? That's 180, 90. This isn't going to be exact because I'm not using a scale. 270, 360, and I'm going to put in halves here because I know my amplitude is a half. There's 1. So if I just graph this with C is 0 and D is 0, well, it would be my normal sine function that has a period of 180. Important points every 1.5 ticks, even though we never wrote all the ticks on there, did we? And it's going to look a bit goofy because it's stretched. My scale's not perfect, but and this is just some rough work. Notice that this goes through the point 360, 0. But this says it needs to go through this point right here. Right? This is the point 361. So right now, this graph matches with C being 0 and D being 0. So what do we need to do? Well, one solution would have been to move it up 1 unit, right? Just move this graph up 1 unit. Well, what does that do to the equation? Up 1 is a C value of 1 with no phase shift, right? Because if I phase shift away from that point, I'd be going left and right from there, and then it would mess things up. But that, that looks pretty good. If I pick up 1 and a phase shift of 0, then I can write an equation. Y equals 0.5 sine of b is 2, and notice my d is 0. My d is 0, so I don't need the inside brackets or the square brackets. 2x and then plus 1. State key features and sketch the function that you wrote in part A. Well, these are the ones that we weren't given, but we've got a vertical shift up 1, or an axis is y equals 1. And my phase shift then was 0. I just moved everything. I'm just going to move everything up 1 here. And so now I want to sketch it. This graph's a little bit small, isn't it? Oh well. Suffer. Some wasted graph paper. That's okay. That's 90, 180, 270, and 360. And now if I just look at this, and I know how to graph it, I hope I'm going to maybe every, let's see, this will be 1. Yeah, let that be 1. And then my axis is up 1. I wonder if I'm going to try and zoom in a little more here even. And then my sine graph, I know starts at no phase shift, so there's my starting point for my sine graph. Maybe choose a different color here. Starting spot for my sine graph. Important point, like once I got my starting spot, then important points, normally every 90, but my b values too, so every 45 degrees or every 1.5 ticks. So my next one is high, which I go up to 1, but the amplitude is only 0.5, isn't it? 0.5. And there, every 1.5 ticks. 1.5 ticks. I'm kind of excited, well, interested, motivated to see whether it goes through that point 361. And there it is right there, isn't it? There. So that's like we're winning. Okay. Well, one thing that we never really answered in part A is more than one equation possible? It doesn't really feel like it is, but in fact it is. There's lots of equations possible because, we could have, moved it up 1 and then went down first instead of up first. We could have made that a minus. You probably see that if we went up 1 unit and then had a phase shift, or we went up 1.5 units and had a phase shift, so this point ended up there. So is more than one equation possible? Yes. Because essentially this combination just has to work out so that we get a point there, and there's an infinite number of answers. Okay, where am I? What am I doing? Zoom. All right, that's it for this slide. Yep. So I got time for, yeah, well, let's do this one in this video, and then we'll do a, well, let's see how much time, what's time. Okay, I'm going to stop there and pick it up in part 2.